Hi everyone, welcome to August Ballyhoo by Science. Today I would like to tell a story of a poor fingermark who lost his identity and was helped by a forensic group at Curtin University to find his identity back. What you are about to see is his journey through the three beamlines at Australian Synchrotron and what we discovered from him over a number of years. However, before going any further, I was told to emphasize that, yes, this is terahertz by size, okay? As everyone could guess, this story revolves around forensic science, and to most of us, this would be the first thing that comes to mind, right? That is not wrong, but what's actually the forensic science? According to International Association of Forensic Science, forensic science is a case-based, research-oriented endeavor using principles of science to study and understand traces through their detection, recognition, examination, and interpretation to understand numerous events of public interest. And this is why Australian Synchrotron come in, and I'm so excited to tell this story. First, I need to emphasize that this story will involve only the finger marks, which are often used in the criminal investigations to connect an individual to the crime scene. Because a large majority of finger marks remain undetected, requiring chemical or physical treatment to be visualized, and therefore this research aimed at using cutting-edge technology here at Australian Synchrotron to increase detection and recovery. And hopefully we will be able to provide a better understanding of fingermark chemistry. Now, let's get to know the fingermark a bit more. In general, fingermarks are made up of three main compositions. First, acrin secretion is basically the sweat from the palm and the feet, which is an aqueous mixture of amino acid, protein, urea, and salts. Second is sebaceous secretion, which is a mixture of lipids produced by sebaceous glands, which is all over your body, especially where the hair is. Then the rest involves contamination such as dust, cosmetics, or food residue, but could also be traces of drugs and explosive residue that could be used as forensic evidence. And now let's join us the journey to the three beamlines and see what we found. First, we came to the IRM beamline and asked him whether we could monitor changes of organic components in the same fingermark residue over time without disturbing it. And Pim said, yes, just stamp your fingermark on our macro-ATR crystal and keep on scanning. Yeah. This way, the fingermark could be analyzed fresh and pure without any chemical interference. After collecting the data every hour for 12 hours, we plot the water and lipid peaks as a function of time. And you can see it here. This is the water and the lipid. Now we can understand how the concentration and distribution of water and lipid in the fingermark droplet change over time, as well as the rate that it changed, which is very important because this makes us understand the persistence of the fingermark. And this provided a crucial information to the police forensic division on the importance of a timely recovery and the correct storage of fingermark evidence from a crime scene. Then, by looking at changes across 12 donors, the acrin materials from the sweat show a gradual decrease in all cases as a result of water evaporation that make the fingermark dry up. Makes sense? Yes. The sebaceous lipids, on the other hand, both increases and decreases over a 12-hour period, suggesting differences in lipid composition, which led to different lipid chemistry between different donors, and this could be related to the donor identity. Next, we move to terahertz beamline. Instead of looking at water left in the finger mark, John came up with a very, very crazy idea that we should be able to quantify the amount of water evaporated from the finger mark using his gas cell setup by putting the finger mark into the furnace, and the water in gas phase will then transfer into the gas cell for analysis. In fact, the topic about evaporated water from the finger mark and sweat has been debated in the forensic community for a number of years. This because of the challenges in working with such a dynamic and small amounts of residue. And so we took the challenge, starting by practicing how to apply the sweat from 10 fingertips onto the glass lot like this. After that, we collected spectrum of the water at different amount in order to create a linear calibration curve like this. Then we tested this system by correcting spectra of actual sweats from 10 fingertips under 3 conditions. First is the normal routine hand without any control in blue. Then the hand without touching anything, but stay in the room temperature in the pink. And the last one is the hand after wearing gloves for 10 minutes in orange. The result makes sense that we saw higher volume of water in sweating hand that did not touch anything compared to the hands that has been working on the normal routine here. These values also agree with some previous reports, and therefore gas-phase IR technique show a potential for the quantitative analysis of water lost through the evaporation in the finger mark. For the last beam time here, Daryl helped the team to use XFM technique for observing the distribution of trace metals in the finger mark. And the result was quite interesting that we found a number of metal in the finger marks depending on the routine and activities of the donor. We even found an increase of copper and nickel from the donor that hold 20-cent coin in their hands before the measurement. It was also observed that cosmetic users show a unique co-localization between titanium and zinc at a significantly higher amount than general donor. These results show how XFM technique can be used to detect metals which could provide information on the activities of the donor for forensic purposes. In the final series, the team moved one step forward into the use of the weapons by looking at finger marks after handling a series of forensic objects, including cartridge case, gun barrel, and party sparkler, which were provided by the Western Australian Police Forensic Division. Comparing between the clean finger mark in all 3 cases, the result clearly show the presence of the metal characteristic to these objects, which suggests just how easily this metal can be transferred into a finger mark. And the result from all 3 beam lines clearly show the outstanding advantages of synchrotron techniques that make this research possible. These include better detection limits, best possible spatial resolutions, and fast correction time. And once the lost finger mark found home, he has been on so many journal covers, making him happy ever after. Finally, I would like to acknowledge the Curtin forensic team led by Professor Simon Lewis and Associate Professor Mark Hackett that brought their team to use our synchrotron facility for so many years, and they're still trying to spread their wings to other beamlines. Lastly, I need to emphasize that this forensic object won't be possible without Dr. Rhiannon Bosley, who makes sure that she danced off and she used every bit of the photons every time she was here for her beam times. And finally, thank you for your attention from all the members of microscopy group. Thank you.